The rim is one of the easiest modeling parts, and yet, it could be hard to create. It depends on what technique you are following to create your model. In this video, I am going to create the base for this concept rim by using the diagonal technique. The main goal of this tutorial is to explain the diagonal technique that I used to create this part. This is what we are going to create in today's video. This is a concept design, and it means I am going to create this design without a blueprint. We are going to make 3 levels of detail of this concept design. The one you see right now is the highest level of detail, or the highest resolution. We will use this later to create the texture for the rim. For this version, I am using 3 iterations in the Turbo Smooth modifier, which means insane amount of polygons. And for the first level of detail, I am going to use 1 iteration only. The amount of polygons still way too high. I will reduce this amount to a reasonable count during the cleaning process after committing to the Turbo Smooth modifier. The base, without the Turbo Smooth modifier, and without the supportive loops, is going to be the second level of detail. There are some details that we can fake by textures, such as the emblem and its surrounding circle. We will uncover this in the texturing tutorial. Good day everyone and welcome to this tutorial. First, I need to mention that you can use 2 different ways to control the width, or the thickness, of those pillars, or arms. One of them is by using the scale tool. You need to be at the local coordination system while scaling the width loops, and it is better to use uniform scale. By this way, the effect of the scale tool will be copied to all loops from the reference local loop that you are scaling. The second way is by using the length script, and this is going to be the method of choice in this tutorial. However, it is up to you to decide which method best suited to use. Let me remind you, I am using meters as system unit and generic because I do not need the unit indicator beside the numbers. The cylinder on our scene is 17 inches diameter, or 21.5 centimeters, at the radius. This means we are creating this part, as well as other parts, at the real-life scale. The width of the rim is represented by the cylinder height, and it is 25 centimeters. I am using 3 segments for both the height and the cap. For the sides, I am using 30, because it accepts dividing on 5 and on 2. We can use 20 or 10, it depends on the number of iterations one is targeting on the Turbo Smooth modifier. In our case, I am targeting 1 iteration. This is why I am using 30 sides for the diameter. As long as the cylinder stay at this state, we can change any of those values. However, once we apply the Edit Poly modifier, we cannot change them. The beginning of our hard surface modeling start after applying the Edit Poly modifier on this cylinder. On the left viewport, select all polygons on the left side, with Ignore Back Faces option enabled. Use the Insert tool to insert a supportive loop at 5 mm length from the edge, then add another with 20 mm length from the previous. I am going to move some of these side loops on the x-axis in order to curve the side surface. Select the side polygons in this sequence, then use the Insert tool to insert a loop with 5 mm amount. Use the Bevel tool to create depth for the pillars with the given constants. Select the side polygons in the exact sequence as shown, then repeat the previous operations to create the other side for each pillar. I am going to scale down these polygons to a reasonable size for the emblem. I am scaling down these vertices to shape the rim mounting base. Now, we can take these polygons to a better place. When using Select Similar, you need to deselect the polygons that you do not need. Otherwise, you might end having this. Fortunately, we do not need to model this side. Here, I am defining the shape of the circle that will contain the emblem. Just by using the Scale tool, we can manipulate the design and create different rims. I am going to use the space operation from the loop tools to even the distance between the edges of the selection. Let's create the mounting holes. I used the loop regularize script to create a circle from each polygon's selection. Technically speaking, to equally distribute each polygon's group outside loop vertices around the group center. You can use make plane operation before applying the bevel, or after, and correct the location of the holes with the scale tool. However, it is better to perform make plane operation on the selected polygons before using the bevel tool when it comes to precision. We are adding these details to create the texture later. Make sure to select all the ring edges before adding the supportive loops. you can add the missing supportive loops, and connect them to the existing, or remove the existing, and add a proper supportive loops. Rather than detaching each side polygon, we will detach these bolts later to remove the chamfering effect. Usually, the mounting base for the rim has cylindrical shape. Use turn loop to circle operation from the loop tools to correct the mounting base shape. To adjust the gizmo's size, go to Customize, then Preference Settings. At the beginning, make sure to center the rim to the world, while it was just a cylinder, before doing any modeling. To center the current design to the world, go to Adjust Pivot menu, then Affect Object Only, and Center to Pivot. After completing the design, the center of the rim as an object might not be at the exact center of the previous cylinder. It is crucial to keep the pivot at this location, and do not change it or align it to the center of the object. The rim pivot location is going to be the center of spinning during animation. This is one of the many reasons we started modeling the rim at the center of the world, and this is why we centered the rim to the pivot's exact location. In this part, I am going to show you the technique I used to create this emblem. I created the half sketch of the emblem, then I used symmetry on y-axis to mirror the other half. You might notice the supportive loops around each hole. This is how you should make any holes on a surface. Then, I applied the bend modifier to bend the sketch on z-axis. After that, I added the shell modifier for thickness. Finally, I added the turbo smooth modifier with 2 iterations. Once you have a clean design topology, you can upgrade its resolution to the desired level. As mentioned, we are going to use this emblem only to create the rim texture. With the right plan, and by using this technique, you can model whatever design